Hi everyone, my name is Bello Abdulaziz, and so in today's class in it, we're going to be discussing about a transistor because in our previous class we discussed about resistors, LED, diodes, and capacitor. So in today's class we're going to be discussing about transistor, and these are our objectives. We'll be discussing about what a transistor is. In case you haven't seen a transistor before, you will learn something about it. We'll discuss about types of transistor, and we'll discuss and we're going to identify the part of the transistor, and most especially the NPN type, because that's what we're going to be discussing about today. I want to also explain about how a transistor is acting as a switch. Then we'll do some practicals, discuss about the application of transistor, and we're going to end the class. So stay with me as I'm going to be discussing about all this. First thing is, what is a transistor? Now, you might have been hearing it since you are new to electronics. You might have been hearing the word called transistor. Transistor. And you'll be like, what the hell is this word? So now, before I actually define what a transistor is, we need to break down this transistor. Now, in this transistor, we have two things. We have transfer and we have resist. So now a transistor is something that can what? That can allow current to flow and also block current from flowing. So that means a transistor can act as a what? It can act as a conductor. It can also act as a what? Insulator. Now what does that mean? It means that a transistor does two things. It acts as what? Conductor, and also acts as what? Insulator. Or let me just put as resistor. Now we know that in electronics or on a common terms in physics, chemistry, anything you want to say, we have conductors, we have semiconductor, and we have what? Insulators. So now the only thing that can do both transfer and resist is what? Is a what? Semiconductor. And boom, we have already defined a transistor. So we say that a transistor is a what? Is a semiconductor device that can be used as a switch or an amplifier in a circuit. Or a transistor is a what? Is a semiconductor. Semiconductor that can be used to on and off signals in a circuit, and it can act as two things. It can act as a what? It can act as a switch. It can act as an amplifier. So it means that this transistor, it is a semiconductor. That means it is not a pure conductor. It is not also what? It is not a pure insulator. It is in between them. How is it between them? It means that at some specific condition, the thing can conduct electricity, and at also some specific condition, it can also what? It can also prevent electricity from flowing. So what I say transistor is? A transistor is a semiconductor that allows current to flow in a circuit under some certain condition. Or a transistor is a semiconductor that can be used as a switch or an amplifier in a circuit. So that is that about the definition of a transistor. So I'm going to go next to what? Types of transistor in a circuit. Types of transistor. Now, types of transistor. As we all know, transistors have various types. It's not just only one type that the transistor has. But in this lesson, we'll be discussing about one. But I want to list the three types of transistor that we have. In transistor, we have number one, BJT. The word might look funny, but the full meaning of BJT is bipolar junction transistor. Number 2, we have FET. FET, F-E-T. That means field effect transistor. I'm going to be discussing on them, but I'm going to major in today's class in BJT. And the last is IGBT, meaning insulated gate bipolar transistor. Now, as you all know, I said that a transistor can act as a what? It can act as a switch or an amplifier, but mostly it is being used as a switch in a circuit. Now, when you say that a transistor can act as a switch, it means that it is different from those mechanical switch that you have to turn on by yourself, on, off. It's different from this type of switch. It's a type of switch that uses signals to operate. And you know that in electronics we have different type of voltage. We have 5 volts, we have 12 volts, we have up to like 300 volts, we have up to like 1000 volts, we have up to like 6000 volts, and so on. Now, as you all know that not all switch can carry 300 volts. Some can carry 5 volts, some can carry 12 volts, some can carry maximum 300, some can carry maximum 1000, and some can carry what? Maximum 6000. So that's the same thing as these transistors also. They all have different ways or different applications that are being used. This BJT, there's a BJT that can carry maximum highest 100 volts or highest at all 150 volts. Field effect transistor, we have one that can carry up to like 200 volts, 300 volts. But these IGBT are being used in electronics that require high voltage. So it means that these bipolar junction transistor, field effect transistor, and what IGBT transistors have different applications and different fields that are being used. But in many projects, we mostly use BJT transistor because apart from the fact that BJT transistor can handle lower voltage, it requires just very minimum voltage for it to operate. So now, in electronics also, the most common BJT transistor that we have, is the NPN. That was what I said earlier, because we're going to be focusing on NPN transistor and also the PNP. While for FET, it is mostly, we have 2 types. We have the MOSFET. And we have the JFET. If you can see, the most common thing between them is the what? Is the FET. Meaning that both of them are what? Field effect transistors. This one, metallic oxide semiconductor field effect transistor. That means metallic oxide semiconductor field effect transistor. The FET means why this one doesn't mean junction. But most especially we use MOSFET, and that is what is mostly common in electronics. Why IGBT? They mostly use IGBT for that. So now, for this class, we're going to be discussing about the BJT transistor, and we're going to be focusing majorly on what? The NPN transistor. So now, we have discussed about what is a transistor, we have discussed about the types of transistor, which are the BJT, FET, and also the what? IGBT. So now the next one we're going to be discussing about is what? We're going to be identifying the parts of the transistor. And in this section, we're going to be discussing about examples of different NPN transistors. What the L is an NPN, so sorry, what the L is the NPN transistor. Why we need it, how to cook it, that means how to burn it without using the right values. When I mean how to burn it, that means we're going to discuss about it though. Because in electronics you have to be careful, and that is why a resistor is needed. And that's why you see that apart from using a resistor to prevent the sacrifice of a lead, you also need a resistor to prevent the cooking of your transistor. Now, we're going to be looking at the words BJT transistor, that means the words the NPN transistor. NPN. Now, if you look at the NPN, you'll be like N. N means negative now. N means negative. And P means positive. You now be like, when we mean NPN, we mean negative, positive, negative. No, that's not the meaning. The thing has to come with a lot of deep story in physics. So let's leave electronics a little bit and dive into physics. So now in physics, we have what we refer to as what? Semiconductor. Semiconductor. And when I say semiconductor, that means listen, a material that has the ability to conduct electricity and also has the ability to tell electricity. No, I'm not conducting it today. So that is what a semiconductor. And in semiconductor, we have different materials being used. We create semiconductor with silicon, most especially silicon, and germanium also, and other unidentified materials that I don't really know, but most especially we use silicon because silicon is more abundant in earth. That means it's very easy to see silicon because the silicon is in sand. This is the formula for sand. SiO2. So it's very easy for them to extract silicon from sand. So that's by the way. Now, if you look at the semiconductor, we have two types of semiconductor. We have intrinsic. For those of you that have done this in your physics, we have the intrinsic semiconductor, and we also have the what? Extrinsic semiconductor. So intrinsic semiconductor is a semiconductor that has equal number of holes. That means number of holes is equal to what? Number of electrons. But in extrinsic, it means that it is either we have number of holes greater than number of electrons, or we have what? Number of electrons greater than number of holes. That's another word. I'm not doing into physics like that. So now when we have number of holes greater than number of electrons, that is a P type of semiconductor. And when we have number of electrons greater than number of holes, that's when we have the N type of semiconductor. And there's a reason why we have this different type of this, but I'm not discussing about that today. So this P type and N type is what is in this NPN. That means this N is discussing about the what? N type of semiconductor. The P is discussing about the what? P type of semiconductor. And the N is discussing about the what? N type of semiconductor. So it definitely means that what? Definitely means that an NPN transistor is a BJT transistor. BJT, that's why you see they said bipolar. Bipolar. Different type of polarity. So a BJT transistor is a type of transistor that contains N type, P type, and what? N type again. Because a transistor, a BJT transistor is just like a diode. Because if you look at it, a diode is just like a what? PN junction. N junction. This is just like a diode. A diode, you can say diode like this, PN. Diode is going to be like this, where you have something like this. I talked about this in the last class. This place is the P, white place is the N. Like this is the diode. Diode. Where this place is the P, that place is the N. But most especially cannot say positive or negative. But what is actually there is that we have the P type of the semiconductor at the N type of semiconductor. Now you might be wondering that is a bipolar junction transistor, not like when you just combine two diodes together. Like you just say, okay, can't you just do like this? This is a PN diode, and this is a PN diode. Now you see, you just take two diodes and combine them together. Then you literally form a PNP. No, that's not how the thing works. I'm coming. This is the P. This is the N. Because on the diode, if you see this sign is the N type. So you now mean that if you combine these two things together, you have already formed a what? P, N, P, N. No. This is not how a transistor is formed. It is not the combination of two diodes. Because one part is slightly doped than the others. When I mean doped, D or P, E, D. It means that one part is slightly doped than the others. But that's not what we're talking about. So that is saying that in a what? In a transistor, it is not the combination of two diodes together. No. Now, this is mostly the symbol of the transistor in a circuit. And the reason why I am focusing on the NPN transistor is that it is mostly easy to understand than the PNP transistor. So now this is the symbol of a transistor in a circuit. This is the emitter, this is the collector, and this is the base. It usually have a round circle. And since we are dealing with NPN, this place is the N, this place is the P, and this place is the N. And if you can look at something, you see that this base and emitter is not like the diode also. If you can see what we have here, we have something like this. I'm focusing on this, and we have this. If you extract it out, we'll have something like this. And you know what I said it in the last class that a diode, this place is the negative of a diode, while place is the positive of a what? Diode. So this symbol is telling us that the relation between the base and emitter of a what? Of a transistor is just like a diode. This N is the negative of a diode, this P is the what? Positive of a diode. But remember, the main meaning of the PN means that it's a what? N type, P type, and what? N type. So now we have different type of transistors, and most especially we have different types. We have C1815, we have 2N2222, we have SS8050, we have BC547. And now the thing about a transistor is that and we have different brands. We also have different manufacturers producing them. So most especially, the thing is that this for a C1815 transistor, the pinout is different. And if you want to identify your transistor, it's going to be like this. If you look at a BJT transistor, it's somewhere like this. This place is flat. Is now having a round curve at the back. But that place that is always flat is where the name is being written on. C1815. Then they'll put three pins. 1, 2, 3. For this C1815, this place is the emitter. This place is the collector. And this place is the what? Is the base. But for 2N222, 2N2. This place is the what? Emitter. This place is the what? Base. This place is the what? Collector. So you can see that the both of them are both what? NPN transistor, but their pinouts are different. This is ECB, this is EBC, and other transistors also. But that's to tell you that if you are doing a practical with a transistor, if you don't know the real pinout diagram, you must have to go to Google, search for the transistor and check for how the pins are being arranged. And most especially to locate the pins, you have to locate it from where the name is being written on. That means from the flat side. So before I go to the next topic, let me show you what I'm saying about by going online, searching for two different types of transistors and showing you the pinout diagram. Can you see what I say? Now I'm live on Google and I typed what C1815, and this is the transistor here, C1815, though you might not be able to see it clearly because of the camera. Now as you can see, when I look at the C1815, based on what I said on the board, the pin 1 is the what? Emitter, the pin 2 is the what? Collector, and the pin 3 is the what? The base. And look at the symbol of the what? NPN transistor. It is a what? NPN transistor. Now can you see? Pin 1 emitter, pin 2 collector, and pin 3 base. And also look at the flat side I'm talking about. This is the flat side. This place that the name is being written on is where you start identifying your emitter from, your collector from, and also your base. But this round place, yeah, where there's nothing written on, you don't need that place. It is this flat place that you are going to need. So also let's start for 2N222. 2N222, and let's see. So you see that different transistors have what? Different pinout diagram. So let's look at a picture of it and let's use this. So now if you can see, for the 2N222, as I said earlier, the pin 1 is the what? The pin 1 is the emitter. But now the pin 2 is the what? Is the base. And the pin 3 is the what? Is the collector. So you can see that they're different. Though they're still having the same, symbol. And they're still having, two of them are still NPN. But if you look at it, the pin 1 is the what? Emitter. The pin 2 is the what? Is the base. While the pin 3 is the what? Collector. Can you see that it's different from C1815? So it means that if you are doing a practical, you must have to what? You must have to check for the pinout configuration so that you won't mess up your circuit or cook your transistor. But although if you have known the pinout diagram on your own, you can decide to run it by yourself. But for safety, I would advise you search for it and check for the pinout configuration. So that is that about a transistor part. We have the what? Emitter, we have the base, and we have the what? Collector. Now let's go to the next topic. Our next objective is what? I was talking about how a transistor is acting as a switch. As I said earlier, a transistor does two main functions. It does two main things. A transistor acts as a what? Switch. And it also acts as a what? Amplifier. But what we'll be focusing more on how the transistor acts as a switch. We're not building an amplifier now. So now, how does the transistor act as a switch? You see, a transistor has three pinouts. As I said earlier, that's the what? Base, collector, and the what? Emitter. Let me draw the symbol of the transistor. So this is the transistor. As I said, this place is the emitter, this place is the collector, and this place is the base. Now, for an NPN transistor, the thing is that the place that enables this transistor to turn on is the what? Is the base. That means the base is the control room. The base is the control room. And the switch we're about to turn on is like from here. So what I mean is that rather than pressing the switch, the internal switch, rather than pressing it in, the moment you give this base a signal, it's going to automatically connect this place together to this place. What I mean is that if the resistance here, if the resistance is very high, the moment you turn on or give the base a signal, the resistance is going to what? The resistance between here and here is going to drop. Which means that whatever that is here will come to this place. Whatever that is here will come to this place. Meaning that the resistance between the emitter and the collector is going to what? Drop. Now, as I said earlier, the reason why a BJT is commonly used is because to turn on the NPN transistor, the voltage between the base and emitter, if the voltage between them, if the voltage is greater than 0.7 volts, so you can see how small it is. Now take the voltage that should touch that base. Let's say this is the transistor. This is the base. The voltage coming inside is around 0.7 volts. If the voltage coming there is around 0.7 volts, meaning that this transistor is going to what? It's going to turn on. Or it means that if the voltage in the emitter, you have it, let's say it is A, let's say it is X, and the voltage in your base is what? Y. The only way your transistor, especially your NPN transistor, the only way this thing can turn on is if VB minus VE is equal to what? 0.7, or Y minus X is equal to what? 0.7. So let's say that you connect your emitter to ground, to GND. When I mean GND, I mean the negative of your battery. The negative of your battery. Or also called 0 volts. When you connect it to that, it means that your X is automatically what? 0. And let's say that you now bring in a voltage, you put in like, let's say 1 volt or 2 volts to your VB. 1 volt or 2 volts. Now let's do the calculation. It means that what? 2 for Y minus 0 for X is equal to what? 2 volts. Now can we say that 2 volts is greater than what? 0.7 volts. And with that, the transistor can what? Transistor can turn on. Or let's say that the voltage coming inside here is 0.8. 0.8. It will be 0.8 minus 0 is going to give us what? 0.8 volts. But to conveniently have this kind of values, that is why they need to say connect the emitter of your diode and connect the emitter of your transistor to GND, or connect it to the what? To 0 volts, so that it will be easier for the thing to turn on if you supply any volts are greater than 0.7 volts. But let's say for instance, the volt, your emitter was connected to 2 volts. The only way your base can turn on is if you give it something like 2.7 volts and above. Because it means that if your emitter is at 2 volts, your base is at what? 2 volts also. The only way turning can turn on is if the difference between them, that means base minus emitter, must be what? 0.7 volts and above. Now let's say that your base is 2 volts, your emitter is 2 volts. 2 minus 2, what's going to happen? 0 volts. The transistor is not going to work. The transistor is not going to turn on. But let's say that your base was giving 3 volts and your emitter was sitting at what? 2 volts. The difference between them is what? 1 volt. It means that what? Your transistor can start what? Turning on. But now, a BJT transistor is like your tap. Yeah, when I mean tap, it's just like your tap in your house. Let's say this is how your tap is. Something like this. Water is flowing inside. Water. The water is our collector. Water is flowing inside. And the output, this place, is like our emitter. Now, you know that if you just turn your tap a little bit, what's going to happen? The water is going to be dropping down into very small. The water can just be dropping like this. 1, 2, it's going to be dropping very tiny. That is it. It means that if you supply a low current to the base of your transistor is going to turn on slightly. It's going to turn on slightly. That means it's going to turn on not very wide like that. For instance, let's say it is like this. If you supply a low current, to it, the thing is not going to turn on partially. But if you turn on the tap to the highest, what's going to happen? You're going to see that the water that is going to drop is going to be dropping what? Very fast. That means it means that if you supply high current to the transistor at the base, transistor is going to fully turn on. And to determine the current, that is what the resistor is being applied to. With the resistor, by using Ohm's law, you can be able to identify or know the current that is flowing into your transistor. Where we have V is equal to what? I R. So since you know your voltage and you know the value of your resistor, you can calculate your current as V over R. So with this, you'll be able to know whether the resistor you are putting in your base will allow your transistor to turn on fully or to just turn on half or not even turn on at all. I'm glad to tell you that the base of a transistor is acting as the signal input, while the collector is acting as sometimes the output, sometimes the input, while the emitter also. But to turn on the transistor, the voltage across the base and the emitter must be what? Greater than 0.7 volts. And most especially the NPN transistor. For a PNP transistor, it has its own, and for a MOSFET and FET, they have their own. And the reason why a BJT is mostly used is that to turn on it needs just very little voltage, around 0.7 volts. So you can see, unlike IGBT, MOSFET, and the rest that need very high voltage, 4 volts, 5 volts will turn on. So that is that about treating a transistor as a what? Switch. So now in the next objective, we're going to be doing a practical. We're going to turn on a what? Transistor. We're going to turn on the LED with a transistor. This is going to be our circuit diagram, and we're using C1815 transistor. And from the pinout configuration, if this is the C1815 transistor, in case that what you might be using, this P1 is the emitter, this pin 2 is the collector, and this pin 3 is the base. So this is going to be the circuit diagram, and this circuit diagram is going to be turning on this LED with a C1815 transistor. So it means that the emitter, this place, the emitter, collector, and the base, the emitter is going to be connected to the negative of our battery, which I said is the what? GND. That means ground. Ground. So this is our LED. That means light. So the positive of our light is connected through a resistor, and I said at that time that the resistor helps us to prevent the sacrificing of our LED. Now when I mean sacrificing, that means to prevent our light from burning due to high current that is going to be flowing inside. So the positive of our light plus minus. Positive of our light is going to get connected to the positive of our battery. And for this base, I'm not going to connect it directly to the battery. It is doing the part I'm going to connect it. That's why I just decided to act like as if there's a switch here. Actually, there's no any switch here. What is actually happening is that I'm going to manually give this base the voltage or signal or whatever it's going to use to turn on. So what is actually going to happen is that this light, it needs negative and positive to work. This positive is already connected, but this negative is not yet connected. And the only thing that is stealing the negative from it is this what? Emitter. And as I said earlier, the resistance between this place and this place is very high, meaning that it is difficult for this light to get connected to this place. So the only way these two guys can communicate to each other so as to allow this LED to what? To turn on or to get its negative is if this transistor should receive a signal and help us reduce the resistance between this place so that this LED can be happy and turn on. And now you might be wondering that what is the difference between us using a normal switch to turn it on and using a transistor? Yeah, in this circuit there might not be any difference in using a normal switch. Because if you use a normal switch, you have to press it, and if you use this transistor, I will have to manually give it a signal. But the reason why they use transistors as a switch is that in case you want to turn on up to like 500 things, rather than using your hands to turn it on, you can just use a signal by clapping, a signal from the sun, a signal by hitting the floor, a signal by motion. So it is the transistor that is going to do the what? They're going to build the what? Turning on, rather than you using your hand to what? Manually turn it on by yourself. So that is what we're going to be doing today, and I have the materials already. This is my C1815 transistor. I'm going to be using this flat side. Okay, this is it, C1815. If you can see it clearly, I'm going to be using this flat side. So in this flat side, we're going to be able to identify that this pin 1 is the emitter, this pin 2 is the collector, and this last pin is the what? Base. Just as how it is in our pinout diagram on the internet. Just as how it is on the internet, this flat place, pin emitter, collector, and the what? And the base. So now let's do it together. So the first thing is this transistor. Just insert it to any place you want on your breadboard. Start it to any place you want, and make sure the flat place is facing you. Sorry about the shadow. This place is dark, so I can't do this video in the dark place. That will have to turn on the lights, and that's why you are seeing a shadow. So after doing that, make sure the flat place is facing you. As I said earlier, based on the circuit diagram, based on this pin here, this pin 1 is the emitter, and from our circuit diagram, our emitter is going to the negative. So take your jumper wire. Take your jumper wire and insert it to the column of this emitter pin, and insert it here. I'm using this place as my negative power supply. This whole place is my negative power supply. While this other place is my positive power supply. So that way you can use any one you want, but just make sure that they're different. This place can be your positive, this place can be your negative, or this place can be your negative, and this place can be your positive. So we have done that. What is the next thing in our circuit diagram? To connect our lights. Now I have different type of lights. Yeah, I have the blue, I have the green, I have the yellow, I have the red, and I also have white. So I'm going to be turning on everything. Now the thing said that the negative of our light is connected to the collector. And where is the negative? I said it in my last video on how to build a blinking LED. That if you want to identify it, this shorter place is the negative, while this longer one is the positive. So connect it there. And make sure you extend it. And make sure you extend the pin. If you can see it, you can see that I drag the pin. If you can see it, I left a space here, because this space is for the base. So I don't want something to be touching each other. That's why I decided to leave a space. So this negative is going to the collector. And the next thing is to connect our 330 ohms resistor. Connecting to the positive. 330 to prevent our lead from burning. And also our 1 kilo ohms resistor to prevent the base from burning also. Now let's see whether we follow the diagram. The pin 1 is the emitter, the pin 2 is the collector, and the pin 3 is the base. Now let's test it. By giving it our power supply. So now I've connected everything, and now I've connected my power supply already, but the light is not turning on. Now let's connect the base to the positive power supply. So let's see what's going to happen if I give the base a signal. Can you see? Can you see that until the base got a power supply before they turn on the LED? If you disconnect it, it's going to go. And the reason why the thing is turning on is because the emitter is sitting at 0 volts and the base is sitting at 5 volts. So 5 minus 0 is 5. So that means that it's greater than 5 volts. And it's greater than 0.7 volts. But now let's see what's going to happen if I put the emitter at 5 volts and the base also at 5 volts. Now see, the emitter is 5 volts and the base also is at 5 volts. Can you see what happened? The thing did not turn on because of the difference between them is 0 volts. But let me put it back. The emitter should go back to 0 volts. Can you see? So that about a transistor. A transistor helps to act as a switch when you give it the right signal. And for it to conduct, it means that the difference between the voltage at the base and emitter must be greater than 0.7 volts. So let me change the color to another color. So now this is it with color blue. Can you see I think say turn on? Because the transistor is acting as a switch. And let me disconnect the signal. The thing did it turn off. So that is about the transistor turning on as a switch. And that's about the practical section of a transistor. Now the application of a transistor is that a transistor is mostly used in different places. Like now in the CPU of a computer, it is the transistor that is being filled up there because you have billions, millions of transistors in a CPU. And all what they are doing is towards on, off, and that. And the transistor is mostly used in different applications, like in the application of detecting whether we're in the day or in the night. It is a transistor that helps us to turn on the load and others. The transistor can also be used to drive a motor, a relay, and different other applications. So that is what a transistor is all about. So thanks for joining today's class, and I hope to see you in the next class. So that is all for now. And also make sure that before you use your transistor, go to Google and look for the pinouts for it, so you won't end up damaging your transistor. And the reason why there's a base, this one there's a resistor in the base, is to protect the transistor from cooking or from burning. So that's why.